So welcome to the channel. Today we will develop code in Google Earth Engine for the trend or analysis of vegetation for a specific region using NDVI vegetation index and non-parametric statistical tools such as Kendall style and sand slope. First, if you're not familiar with Kendall style, so you're probably familiar with parametric tools such as regression analysis and correlation analysis, but there are also non-parametric tools such as Kendall styles and sand slope. They are to some degree even more robust and valid for non-standard distribution and the data with high variance. And they're quite often used for trend analysis, for climate studies, etc. So today we will use it for NDVI. So Kendall style correlation coefficient. Kendall style measures the strength and direction of the monotonic trend in NDVI time series and in general in time series. Using this formula, tau, it's like the correlation coefficient for regression analysis, but it's computed slightly differently. So it's the number of years in the time series. We will take 20 years. X, Y, X, J are the NDVI values at different times. So this one. And the sign X, Y minus X, Xj minus XY plus, it means it's if the following NDVI is bigger. For instance, let's compare the NDVI of March and February. Of course, March will be bigger. Therefore, it will take +1. But let's compare the NDVI for August and September, the following months, it will be minus. If there is no difference, for instance, between May and June, it will be 0. So it will sum up and multiply to 2 and divide to this, and tau will be from -1 to 1. 1 is plus upward trend, minus is downward trend, 0 is no trend. So this score, it's for statistical validity of the Kendall style. So this is a Kendall style coefficient which we will compute before, and the number of years. So is this greater than 1.696 or less than indicates a statistically significant trend at the 95% of confidence level. And the last is the sand slope estimator. If the Kendall style shows the upward or downward trend, upward it means greening of vegetation and study area, and downward meaning browning. Sand slope estimates the value of trend, so the scope of trend. So it's computed using this one. So sand slope provides the magnitude of trend by estimating the median slope between all data points. So median, it's a trend line. So it's xj minus xy NDVI divided j minus y. So xi and xj are NDVI values at time I and j, and represents the time difference. So positive slope greening trend, increasing with negative slope is browning trend. So let's open this Google Earth Engine so first I will upload the study area. So let's go to file global administrative units. This is my file shapefile. See, let's import it and name it file. So I want to add map, add layer, my file. And let's run it. I need for my country, for Uzbekistan. Let's go here. This is my administrative boundary that I need. So let's go to inspector and click on it. So let's open which properties it has. So it shows shapefile properties, Uzbekistan, Kashkadarya, Shahrisabz district. So, and I need to select War Shah subs. My study area from file filter search engine filter equals to, so this is admin, this is the study area I need, so this is metadata, and this is the district I need. So I want to test it. Map at layer Shahri subs. So first I don't need I can change it to name file and make it false, because I don't need to upload it every single time. So let's run again. So see, my already study area is highlighted, no, I mean delineated. So it's my study area. I can also open the whole shape feature collection, but I don't need it anymore. So and this is not the end. Let's convert it to this study area to Shahri subs geometry, because we will use it further in our code. So I turned it into geometry, and now first we will work with NDVI MODIS. So this is an image collection of MODIS Terra vegetation indexes. So you can see that the NDVI is already computed. Resolution 250, not very high, but it's suitable for our research for starting 2000. This is image collection name. So let's copy it and paste it. So this is a image collection, and I need to filter for my geometry, and also extract this high quality images for NDVI. So first filter date, but filter bounds geometry. So, and I will map a function through my image collection image. Yeah. Var mascot equal image select. So there is if you go to properties, summary QR, so which shows the reliability of vegetation index pixels. I can copy this field and I need to equate it to 0. Close. Return image update mascot. Close. And map again. Function image geometry. So I clipped this geometry. I need to close it. Close it. And let's print dataset. Run. We can name it dataset filter. So these are the 574 elements. Next I will create list. For years. I will work with 2002 to 2022. You can choose your own years, but remember that this image collection starts from year 2000. And now months, also year list sequence from 4 to 10. These are the growing years. But you can choose your own growing years. It depends on your study area and vegetation period. So next I will create the image collection monthly equals from images years map function year for each year so return. Now I will work with months list months I think that one is unnecessary. Return months and now I will create this average NDVI for each month using the when I so since the several months might contain two images, I will use the highest NDVI pixel value, and the final image for my study area will have contains the pixels of the highest NDVI value for each month if there is more than one NDVI image, MODIS image for the months and year. So dataset filter calendar range years because it's the same year filter. So again filter calendar range months months, because for the same months, select. Now I will select NDVI, and I will take this maximum pixel. So now I will set the metadata year. So for the year, the same for the months, and taking the months, and system time start, taking year, date, year, month, day, year, months, day 1. Well, I mean it will be assigned as a day 1 for each month. But you can make day 30 or 31, 30 for instance, doesn't matter. Monthly max, return monthly max. This here is monthly max, yes. So I just took it monthly max. So let's count how many I think it's fine now, because this one should be closing. Flatten, this is for yeah, for this one. So I think it's now correct. And now let's test print monthly. Date. I wrote it. Monthly. Yes, now it's correct. So monthly. Yes, so see that it contains image collection contains 170 elements, images, and each image contains one band NDVI with properties, month, system index, year. See, so this is for month 4, year 2005, and system time start, this one. So far so good. Let's move on. And now we will contain mean NDVI. No, I mean, yeah, mean yearly NDVI from monthly max. So we need to find the trend of NDVI for the 20 years for this period, and we will compute this mean NDVI for each year using this monthly max, and then we will compute Kendall's tau from this. So again, we will create image collection. So years, as we used before, list map function image No, sorry, let's make it year. Var yearly. So monthly. So we use this image collection above. Filter, we use filter calendar range, year, select NDVI and compute mean. And yes, the same set year, and return yearly. So what did I miss here? No. Yeah, we need to corroborate this. Give var yearly, monthly, filter calendar range. Yeah, I forgot here a comma. So yearly. So this is a code for computing the I create this yearly image collection, which will take years for this list of sequences. For each year, it will compute this monthly. It will take this monthly image collection, which I also created, from which contains this 170 images from monthly in the NDVI, and for each year, for taking this necessary property this year, it will compute this select NDVIs. It will take 1 year and compute this mean NDVI for this year, and it will return this 20 images. We can compute it. We can test it. Yearly NDVI mean. It will create this image collection containing this image, so 21 for each year, right? Properties, year, system times this, so year 15, and the band NDVI, so 21 images, image collection containing 21 images. Yes, and let's move further. And the next thing is var NDVI trend. So I will take this yearly and use this reduce function, reducer. There is an inbuilt function named Kendall's correlation. Yes, it found. So yearly reduce reducer. So it will compute this NDVI trend taking yearly for Kendall's correlation, as I showed in the formula above. And before let's finalizing, let's create this visualization parameters. Minimum it will be -1, maximum it will be +1. So palette what is wrong here with the visualization parameters? Minimum, maximum palette. Yeah, it's var. Yeah. And the last is wow tau correlation. NDVI trend. Select. Now I will write NDVI tau. Map at layer tau correlation visualization parameters NDVI tau. Run. Let's wait. So see, it's computing this NDVI trend. We can go to this NDVI tau layer, stretch it. It's better to change this to probably yellow. Yeah, it's much better. You can change it to this yellow here. So so this is a high tau growing trend +1. This is a, we can just use it inspector. So probably this will be minus. Yes, minus. It's a degradation, and so NDVI going down. This is plus B plus. So NDVI going up. Closer to +1, it's upward trend. NDVI is higher and higher, and vice versa. And now the score. The score. So first 2022 minus 2002. So the difference, and I will create this image. And remember the formula. This one, it's complicated, but we will figure out. Image constant 3. Yeah, it's a whole image with the same pixel value. Tau correlation multiply subtract and subtract 1 square root divide, let's move it to here so the Google Earth Engine would recognize it. Divide image constant, well, no, 2 image two, yes, multiply m yeah, I expected that it will be an error. Where is it? Oh yeah, it should be that here. Unexpected token, I think. One more time, let's no. Yeah, I think now it's fine. Let's try to add the map. Visualization, let's not so far add the palette, the score. Just let's see first. Can close this one. Yes, -1 + 1. Is it correct? Yeah, try to make it absolute numbers. Yeah, it's 0 to 5%, so see that we can change the palette here. So yeah, it's statistical validity from 0 to 5. And the last is compute sense slope. So first bar at year bands, it will be image collection. So yearly map function image so var yearly mean of months slim max image select var year 1 image get year yes so the same will compete year 2 so we'll take string from year 1 and year 3 we will compute number parse. Now it's year 2 which is a string slice 0 to 4 to float and return image concatenation so yearly mean of monthly max NDVI year 3 it will be a list max year set year 3 print sorry, is it correct? Oh, I need to delete this one. Print at year spent. So at year spent. No, it's slice. I think the problem is here, so it should be separate, right? Yes, it's a list from 2 objects. Yeah, and now it's fine. So it's at yearly bands. You can see bands here maximum and the year, so we will compare them using this sense slope formula, and we will use this ingrained formula sense Let's copy this adhere bands, reduce here, reducer, so there is a embedded formula send slope. For our study area, we don't need more, so it will be one image. Print sense. You can read about this formulas, Google Earth Engine formulas in Google Earth Engine development profile. Information about these formulas. Yes, let's add them, this as well, send slope, let's take it. So see this minus means this are NDVI values. As you remember, the NDVI value range from -1 to +1. So if the minus is here, so that this the trend is downward and the NDVI is decreasing for the pixel for this value. If the trend is upward, NDVI is decreased for the pixel for this value as well. So there is upward trend. So we can again make a palette here. So 1, 2, 3. Let's make it 4. We can make it 5 as well. Apply. Well, strange that it shows well, some areas are generating, but mostly it's not very high. So yeah, some areas are positive, some areas are negative. You can export it, this image send slope z-score, so it's see that it's statistically valid, significant, and NDVI tau to your Google Earth drive, and see it in ArcGIS or QGIS and use it for the trend analysis of vegetation. I see that these tools are very valuable and useful using in Google Earth Engine for a time series analysis. They show you the final map of how the 13 areas of your study area showing a greening trend, and certain areas we can see that system write it browning and greening. The same with here with tau. So it's very useful. You can use this already ready MODIS images, especially if your study area is high. Its range length, it's also can be very useful. You can see do you have regional degradation or forest deforestation issues, etc.